Okay, in this video tutorial, what we're going to do is we're going to explore how to multiply and divide integers. We're going to start by looking at the problem 3 times negative 4. And to help us understand this, we're going to look at sort of the group or set sort of model of multiplication, where our first number tells us how many sets there are, and our second number here is telling us the amount in each set. So the number in each set. And so the way to think about 3 times negative 4 is what we really have is 3 sets of negative 4. And so to model that, we're going to use our number line. And so what I have here is I have one set of negative 4, and we know that's negative 4 because it goes 4 units to the left, and a second set of negative 4, and a third set of negative 4. And when you put those 3 sets of negative 4 together, you can see that the final answer is negative 12. Right? So in this particular case here, what we end up with is 3 times negative 4 is equal to negative 12. And this will work anytime we have a positive number multiplied by a negative number. Another way to think of this entire problem is we could rewrite this, and we could say that this is the same as negative 4 times 3. And this is that commutative property which says that we can change the order of two numbers in multiplication and it doesn't change the final answer. And so I'm just going to think about this a little differently. Instead of thinking this as negative 4 times 3, I'm going to think of this as the opposite of 4 times 3. So I still have my one negative sign, and I still have my 4 and my 3. Well, we know that 4 times 3 is 12, and the opposite of 12 is negative 12. So this is two ways for us to understand why a negative value multiplied by a positive value is always going to be equal to a negative value. In this example here, we have negative 5 times negative 3. Now this is a little bit harder to kind of model on a number line, but what we can do is we can use that idea of the opposite. And so what I'm going to do is I'm going to quickly rewrite this, and I'm going to rewrite this as the opposite of the opposite of 5 times 3. So what you can see here is I still have my 5 times 3. There's my 5 and there's my 3. There's the 5 and there's the 3. And I still have the same number of negative signs. So I have one negative sign here, and here it is. And I have another negative sign here, and here it is. So I kept the number of negative signs the same, and my numbers have remained the same. So now in this case, I'm just going to use order of operations to work this out. Right? So I know, let's just write that, I know that 5 times 3 is 15, and so now I'm going to work that out. The opposite of 15, let's quickly highlight those again. Here's our one negative sign and here's our other. So what I'm really looking at here now is the opposite of 15 is negative 15, so I'm using my parentheses, and the opposite of negative 15 is, of course, positive 15. And so based on this, we get another rule for integers which tells us that a negative times a negative always equals positive. And this is true no matter what. Now in this particular example, we're going to look at division. And I have the problem of negative 8 divided by 4. So to understand this, we're going to use the whole idea of partitioning. And so the negative 8 tells me my the number of objects, or the length of the line, and the 4 tells me the number of equal groups. So in this case, what this means is I want to divide negative 8 into 4 equal groups. And so to do that, I'm going to start off with a number line. So here's my number line. It represents negative 8, and you can see that because it goes 8 units to the left. Now I'm going to divide that into 4 equal sized groups. And so I know that 8 divided by 4 is 2, so each of my units, or each of my groups, is going to be 2 units long. So there's one of my groups. There's the second group. Here's the third group. And finally, here is the fourth group. And so by looking at that, I can see that each of my groups, and actually I'll just draw some arrows on there to kind of show that, each of my groups here is 1, 2, 3, 4. Each of my groups is negative 2 units long. So this tells me that negative 8 divided by 4 is equal to negative 2. And once again, we can use the other model of the concept of opposites to do this, but this is really the opposite of 8 divided by 4. And I know that 8 divided by 4 is 2, and the opposite of 2 is negative 2. So we get a rule from this case, which is really the same as our multiplication rule, that if we have a negative value divided by a positive value, that is always going to be equal to a negative value. Now our final example here, we're going to kind of do the same idea, right? We have negative 32 divided by negative 8. Now this is kind of hard to use to kind of think about the group, because how do we take negative 32 objects and divide it into negative 8 groups? But what we can do in this particular case is we can use the concept of opposites. So this is really the opposite of 32 divided by 8. And so in this particular case, again, like the last time, you can see that we have one negative sign here, and we have another negative sign there, and then we have our values. Well, using order of operations, we'll start with the innermost parentheses, which is right here. And so I have a negative sign, and 32 divided by 8 is 4. Now I'll use my next set of parentheses. The opposite of 4 is negative 4, so there's that. And then I will find the opposite of negative 4, which is positive 4. So once again, we kind of have a mirror to our multiplication rule, where a negative value divided by a negative value equals a positive value. And this will always be the case, where a negative divided by a negative is equal to a positive